Hello everyone, I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about observability test, state space analysis, control system subjects. Lecture series on state space analysis and lecture number 36. So our topic's name observability test. Overview. State variable formulation. What is controllability? What is observability? Kalman test for observability. Proof of observability. What is observability matrix and theorems on observability? Idea of complete state observability. So this is our overview. Definition, observability definition. A system is said to be completely observable if every state x of t0 can be determined from the measurement of the output y of t over a finite time interval t0 to tf. And another definition, a system with an initial state x of t0 is observable if and only if the value of the initial state can be determined from the system output y of t that has been observed to the time interval t0 to tf. If the initial state cannot be so determined, the system is unobservable. And what is completely observable? A system is said to be completely observable if all the possible initial state of the system can be observed. Systems that fail this criterion are said to be unobservable. So what is observable system and what is completely observable systems? This is the basic idea or definition. Then Kalman test of observability. The state variable formulation of an nth order linear time invariant multivariable system represented by the vector matrix differential equation. Consider the dynamical system described by the state equation. This is the state equation x dot t equals to axt plus bu of t, and yt equals to what? Output yt equals to cxt plus dut. X dot t is called the state equation. Why this equation is called state equation? Because left hand side only differentiation terms and right hand side free of differentiation terms, and this type of equation is called state equation. And this is the output state equation. Y of t equals to cxt plus d into u of t. When d equals to 0, this term equivalent to 0, then what is the output? Yt equals to c into x of t, because d equals to 0. And this condition equation x dot t and yt is called MIMO system. This is called MIMO system, multi-input, multi-output. But when d equivalent to 0, then x dot t equals to xt plus but, yt equals to cxt, and this two equation is called SISO system. SISO, that means single input, single output systems. This is the basic concept. Kalman test for observability proof. Consider the state variable model of a system given and in equation 1 and 2 in the dynamics of linear time invariant system be written in vector matrix differential equation is as x dot t equals to xt plus but and yt equals to cxt plus dut, or x dot equals to x plus bu, y equals to cx plus du. This is the vector matrix differential equation, where A is a constant system matrix of order n cross n. So n dimension, what is the dimension? N cross n. And B is the input coupling matrix of order n cross r. And C is or U is a R cross 1 input matrix, and x dot equals to ax plus bu is called the state equation. The state equation. Again, yt equals to what? Yt equals to output equation. And this equation equals to cxt plus du of t. And y is a m cross 1 dimension output vector. And C is m cross n dimension system matrix. D is m cross a transmission matrix. Yt equals to cxt plus du of t is called the output equation. So this is the state equation. X dot equals to x plus bu and yt equals to cx plus du is called the output equation. Is called the output equation. Proof. X dot equals to x plus bu. Then x dot minus ax equals to what? X equals to bu of t. This is equation number 3. Just right hand to left hand ax transform right hand side to left hand side. Multiplying both sides by e to the power at. This is the very important term, e to the power minus at. Multiplying both sides, this side multiplying by e to the power minus at, this side also multiplied by e to the power minus at, and we get e to the power minus at into x dot t minus axt equals to e to the power minus at bu of t. This is equation number 4. Then ddt of this equation equivalent to e to the power minus at x dot t a minus ax of t equivalent to ddt of e to the power minus at x of t, because this is u, this is v, uv method. U constant, e to the power minus at constant, first term constant, second term derivative, and second term constant, first term derivative a into minus e to the power minus at. So this equivalent to this term equivalent to ddt of e to the power minus at into e to the power minus at into xt, and right, and this is equivalent to this e to the power minus at x dot t minus a into e to the power minus at into x of t, common e to the power minus at, then we get x dot e to the power minus at into x dot t minus axt. This is equation number 5. Then ddt of e to the power minus at x of t equals to e to the power minus at x dot t minus a into x of t, and equation 4 e to the power minus at x dot t minus a into xt e to the power minus at but, and from 4 equation 4 and 5 we can write, this is the left hand side terms, and this is equivalent to also e to the power minus at b into u of t, and this equation, this is the equation number 6, because this is the left hand side terms, and already proved this is equivalent to this term. That's why ddt of e to the power minus at xt equivalent to e to the power minus at into bu of t. Then integrating both sides of equation 6 between the limit, lower limit 0 to t. So left hand side 0 to t ddt e to the power minus atx of t, right hand side also 0 to t e to the power minus a tau b u tau d tau. What is tau? Intermediate times in between 0 to t, in between initial times t0, final time t, and at that position that t equals to tau. That's why e to the power minus a tau b into u tau d tau. Then integrate and we get e to the power minus at x of t 0 to t e to the power 0 to t e to the power minus at b into u tau d tau. Put upper limit minus lower limit. Then first value e to the minus at x of t, because upper limit t and lower limit 0. That's why e to the power minus 0 I, and x of t 0 or x of 0. This is the I into x0, and 0 to t e to the power minus a tau b u tau d tau. Then we get e to the power minus at xt equals to I0 x0 plus 0 to t e to the power minus a tau b into u tau d tau. Then what is xt? Xt equals to, this is the xt. Xt equals to both side divided by e to the power minus at. Both side divided by e to the power minus at, and we get e to the power at x0, e to the power at, e to the power minus at b u tau d tau 0 to t. Then operation these two value, e to the power at and e to the power minus at, and we get e to the power xt equals to e to the power at x0 plus 0 to t e to the power at minus tau, t minus tau b into u tau d tau. This is the equation number 7. So x of t equals to phi of t x0 plus 0 to t phi of t minus tau b u tau d tau. Because by using state transition matrix, phi of t equals to what? Phi of t equivalent to e to the power at. So if phi of t minus tau equivalent to e to the power at minus tau, then when the initial time t0 and the final time tf, then the same equation is, the state equation is, just put t equals to tf, final time tf, and t equals to t0 initial time. Then x of tf equals to phi of tf minus t0, x of t0 plus t0 to tf, phi of tf minus tau, b of u tau d tau, and again put phi of tf minus tau equals to e to the power a tf minus tau. So second equation, this is the e to the power a tf minus tau. This is equivalent to this equation because this is the state transition matrix. This is the state transition matrix. And t0 0 to t and 0 to t, t0 to tf, e to the power atf minus tau b into u tau d tau, where tf final time greater than t0 initial time and phi of t equals to e to the power at state transition matrix. The output equation is yt equals to what? The output equation yt equals to c into xt for CISO system. So put this xt equivalent to this xt or this xtf. Put here x of t value, and then we get x of t equals to phi of tf minus t0, x of t0 plus t0 to tf, phi of tf minus tau t0, b of u tau d tau, b of u tau d tau. Then we get c into phi tf minus t0, x t0 plus t0 to tf, phi of tf minus t0 b into u tau d tau. When u of tau equals to 0, when this is the very important condition, u of tau equals to 0, that means this value 0. This is equivalent to 0. Does not change the definition of observability. The output equation represented as, this is the output equation. Yt equals to what? C into xt. So xt equals to what? Xt equals to phi into tf minus t0, phi into tf minus t0, x of t0. Then applying Kelly-Hamilton theorem. What is the Kelly-Hamilton theorem? Phi of tf minus t0 equals to k equals to 0 to n minus 1 alpha k tf minus t0 a to the power k. This is the Kelly-Hamilton theorem. Just put here in this position, phi of tf minus t0 equivalent to k equals to 0 to n minus 1 alpha k tf minus t0 into a to the power k. Just put here. Then we get the output equation is yt equals to c into, this is phi of tf minus t0, k equals to 0 to n minus 1 alpha k tf minus t0 a to the power k x t0. Then put k equals to 0, 1, 2, 3, 4, dot, 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 n minus 1, and we get, just put here, k equals to 0, just put here k equals to 0, This is the first put alpha 0, tf minus t0, and put here a0. This is the a0, the first value complete. Second value put k equals to 1, just k equals to 1 and k equals to 1. And then k equals to 2, k equals to 2 dot 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 alpha n minus 1 tf minus t0 c a to the power n minus 1 x tf. Just put k equals to 0, 1, 2, 3 dot 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 n minus 1. Then the output equation is this, and the common alpha 0, this is the alpha 0 term, tf minus t0, and xi into alpha 1, alpha 2, dot 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 alpha n minus 1 tf minus t0, and the common c, ca square, ca to the power n minus 1, and finally x of t0. Then the output equation is q0 equals to ca square dot 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 ca to the power n minus 1, or ca square ca to the power n minus 1 whole transpose, or this is equivalent to C transpose A transpose C transpose. This is equivalent to C transpose A transpose C transpose, A transpose square C transpose dot 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 A to the power n minus 1 whole to the power n minus A transpose to the power n minus 1 C transpose. So this is the Q0 matrix or observability matrix. When Q0 rank equals to n, then the system will be completely observable. That means when Q0 rank equals to n, if this is the n cross n matrix and rank equals to n, then this is the observability matrix. That means this is the n cross n matrix. If rank equals to n, the system will be completely observable, otherwise unobservable. Kalman test for observability. Consider the following system: x dot t equals to xt plus but, and yt equals to c into xt, and q0 equals to c ca square dot 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 ca to the power n minus 1 whole into t. Then Kalman test. Consider the following system: x dot t, and this is the output equation, yt equals to c into x of t, will be completely observable if the rank of NP order observability matrix Q0 defined as this: Q0 equals to C square dot 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 C n to the power n minus 1 equivalent to C transpose A transpose C transpose A transpose square C transpose A to the power n minus 1 C transpose is equal to n if the matrix are completely complex. Then instead of simple transpose, we have to take conjugate transpose. The system is said to be completely observable if the state can be determined from the knowledge of the input u of t and the output y of t over a finite interval of time. The observability condition is also referred to the pair A and C being observable. The system is completely observable if the rank of Q0 is n, or multivariable system having p output. The observability matrix Q0 is order np into n. This is for multivariable systems. So Kalman test and conclusion: when Q0 rank equals to n, then system will be observable, otherwise unobservable. Thank you.